Hi everyone, I'm Alessandro Dell'Endice. I'm a senior researcher at the Block Research Group, and I want to present how we are actually applying COMPAS into the CARBCOMN project. So what is CARBCOMN? CARBCOMN is an European-funded Horizon project called Carbon Negative Compression Dominant Structures for Decarbonized and Deconstructible Concrete Buildings. Very long. That involves many partners. So there are 5 academic partners and 6 from industry. And we decided to actually use COMPAS as like a common infrastructure. So we are attaching COMPAS logos to the other institutions. So these are the ones that are already adopting our infrastructures that we are actually building it together. So the CARBCOMN project starts from the past experience from the, let's say, the 2 bridges that we built with 3D concrete printing, and now actually is extending this to more common elements like a floor slab made out of discrete components, 3D printed with like a tension tie running into the block. So this slide summarizes a little bit some of the details. I mean, the geometry looks quite simple, but actually there is a lot of complexity, a lot of layers, like on the design, on the structural point of view, LCA, and so on, that gets integrated in the system. So on this project, I'm coordinating Daniele and Baraa, so the 2 PhDs that are working on 2 different topics. Daniele is focusing on the semantic beam, so building the full infrastructure that will work as a glue between all the partners and all the topics. And Baraa is focusing on the development and extending also the computational part from the structural point of view. Is a little bit an extension of what we started already and what's, let's say, successful between us, Zadid architects, and Incremental 3D for the construction, so from the design to the fabrication of the Striatus and the Phoenix Bridge, but is now building on top of that, adding complexity. So this is a multi-domain model. So it's based on COMPAS model, the one in the middle there. But as you can see, we are adding a lot of layers. For example, I mean, the structure was already there, but for example, the LCA, to have like a real early stage evaluation of LCA, considering the material, which is part of the development of this project, and getting all the input from the architectural design. So we created an infrastructure called CARBCOMN Core that is under development at the moment, and the work of Daniele is actually expanding that in order to have multiple and parallel models that can take care of all the different topics. I will focus a little bit more on the structural pipeline, which is what Baraa is developing, and in particular, just to give you an example of these sub-models that are added to the big infrastructure, I will talk about the discrete element modeling step in the design process. So Baraa is working on the development of COMPAS DEM. DEM stands for Discrete Element Modeling, which is a package that is directly related to CARBCOMN Core. So it's a sub-model which takes the geometry and the material that are given by the designers, then creates a DEM problem, which is, let's say, a solver agnostic definition of the structural problem with all the boundary condition, contact properties, and all the things that you want to test and simulate, and then connects directly this, let's say, problem to like a list of solvers that can be implemented. So some of them are based on commercially available software. Most of them are actually open source. And what I want to show you is the, let's say, the flexibility of this infrastructure thanks to COMPAS, and I will show you also how in this infrastructure we actually implemented like a solver that was not there before, like developed by external partners. And at the end, let's say, because COMPAS DEM is connected to COMPAS Viewer. I mean, we developed a DEM viewer, and the idea in the CARBCOMN is that each submodel has its own viewer, but they can be all read through the CARBCOMN Core infrastructure. So, as I said, I will show you briefly another, let's say, interesting part related to the development of this and related to the, let's say, COMPAS developers. This slide has awkwardly is not centered. There is COMPAS MGC on the right side. The reason is that there is something happening on the left. Everything started with this open source solver for discrete element modeling that was developed by University of Montpellier, which was written in Fortran, so not many people using it. And what we did in this translation, so thanks to Petras and to Claude, as Petras said, there was an implementation from, let's say, the original package in Fortran to like using a nanobind and basically having a binding called COMPAS LMGC 90, which allowed us to integrate this object into the COMPAS infrastructure and then relate this back to our pipeline into the form finding and the structural design of discrete element modeling. Something similar is happening also in the consortium with Zaldid Architects. So they are actually developing or they are willing to share part of their, let's say, code that was used also for the design of the bridges in terms of slicing and post-processing of the geometry for printing, for 3D concrete printing. So the same infrastructure that was used for LMGC 90 is actually applied here as well. So we have a starting point, which is the Z space. So it's this core framework inside the Zaldid, let's say, code infrastructure. And then by using nanobind, they are now making a COMPAS package, which will live into the CARBCOMN infrastructure. And finally, another, let's say, sub-model or another application of the, let's say, this CARBCOMN core is related to the sensor integration. This is something we presented at the conference. So the way how the model is structured and the connection between sub-model allows you also to post-process after the building of something the results coming or the data coming from sensors. And because everything is interconnected in terms of semantic, in terms of geometry and so on, we can always recompute, for example, the structural behavior depending on the data that are measured by the sensor during the lifetime. So during after the building of the project. Thank you very much.